Okay, we're going to talk a little about some basic test instruments besides antenna analyzers and dummy loads. And I think some of this is we went over early on, so it's kind of a refresher. One of the most common things you're going to have is a multimeter that is a combination of a voltmeter, an ohm meter, an ammeter, and in some cases, several other functions. Some of them actually measure capacitance. They can measure transistor parameters, things like temperature, and they're fairly cheap. Usually you can get a decent one for well under $100. In fact, if you go to Harbor Freight, you can get one for free sometimes. It's not very good. It's only functions, but you know, it's good enough for a lot of stuff you want to do. So in the voltmeter setting, you're going to measure volts. When it's in the ohm meter setting, you're going to measure resistance in ohms. And in the ammeter setting, you're going to measure the current in amperes or milliamperes. And a lot of these, in the volts and ohms, they also have several ranges where they'll go for like ohms, kiloohms, megohms, similar for volts. Usually, if you want to measure current, you have to put the test lead in a different jack on the meter because you have to set it up so it's in series with the circuit. Where for volts and ohms, you're going to measure things in parallel. One of the common mistakes that will ruin your multimeter is having it on the resistance setting and trying to measure voltage. It will, as a minimum, blow a fuse in it. It might permanently damage it. Here's a typical, and these are some high-end. This one would cost more than $100 because it's a digital.
No, mine are a lot simpler than that.
I think this Simpson probably goes for a couple hundred. And this old analog Simpson, which used to be the gold standard, if you can find one of those, they probably go for a couple $100 too. And there's nothing wrong with these. They're very good meters. In fact, they have some advantages because if you're looking at a signal that's changing, you can see it with the needle moving. If you're trying to do that with a digital one, you just see a blur of numbers. And you can't necessarily tell what it is if it's changing fast. So which of the following measurements are made using a multimeter?
That was the UPS guy. Delta.
Did you say delta?
I did say delta.
Why did you
How does
say
it measure
delta?
signal strength?
Why did I say delta? I guess it's wrong then. I don't want delta. Alpha.
Why did you think it was correct?
Why did I think it was correct? It probably demonstrates a lack of understanding.
Okay. Well, the correct answer is Charlie.
Oh, man.
They don't measure signal strength or noise, at least none I've ever seen. And most of them, unless it was some laboratory type bench multimeter, don't measure impedance or reactance. So they strictly measure voltage, resistance, and current, maybe a few other things. So which of the following can damage your multimeter?
I
Charlie,
love delta. Yeah.
Yeah, the modern ones don't have to warm up. Now, an old vacuum tube voltmeter, you actually have to let it warm up.
Mm-hmm.
So you can also have a dedicated voltmeter. Usually it's a more of a bench type laboratory grade instrument. And all it does is measure voltage. It may go down into, maybe as low as picovolts. When you're using a voltmeter or the multimeter to measure voltage, you have to put it in parallel with what you're trying to measure, the voltage across. So if you want to measure the voltage drop across a resistor, you would put your leads on each end of the resistor, and it would tell you what the voltage drop was across that resistor. And of course, if you knew the value of the resistor, then you could determine what the current was through it with Ohm's law. They will have multiple settings. The typical multimeter probably goes up usually around 750 volts, but it doesn't go down. Maybe it'll show millivolts, but that's usually the lower limit. The laboratory type, like I said, may go down to as low as picovolts, and they may go up to kilovolts or more. You can have an analog or a digital display. Like I said, in some cases, an analog display is more useful than a digital one. If you're looking at varying signals, like if you're trying to tune something and look at the voltage changing, it's easier to do it with an analog meter. All of them look like a very high resistance in parallel with what you're measuring, so it has minimal effect on what the item that you're trying to measure. You want it to be at least 10 times higher in resistance than what you're trying to measure, so it doesn't have a big effect on it. And the other thing is you need to make sure that it's rated for the voltage you're trying to measure. If you're trying to measure a power supply, let's say in a vacuum tube power amplifier that may be several thousand volts, and you're trying to do it with your multimeter that's rated at 750, it's probably going to be a problem.
could you explain again? Go back to that other slide.
This one?
Would you explain the acts as a very high resistance in parallel, why it needs to be higher by 10 times?
Or more? Well, you're basically putting two resistors in parallel. So, and I think we talked about early on how you determine the effective resistance of two resistors in parallel.
Yes,
Okay.
it's coming back to me now.
So the higher the resistance is of the one you're putting in parallel, the less it's going to change the effective value. So if it was, let's say it was an infinite resistance, it wouldn't have any effect at all. If you're trying to measure, say, the voltage across a 1,000 ohm resistor, and your meter is in the mega ohm range, it's going to have a negligible effect. If it was down and it was only a few thousand ohms, it's going to make a big difference in your reading.
Okay, thank you.
So which instrument would you use to measure electric potential?
Bravo.
How is a voltmeter connected to a component to measure applied voltage?
Bravo.
I thought it was Bravo.
Which of the following precautions should be taken when measuring high voltages with a voltmeter?
Bravo.
Okay, yeah, bravo.
The other thing that you should also do when you're measuring high voltages is hold one hand behind your back.
Mm-hmm.
Which makes it a little
But it
difficult.
don't ground out. Yep.
Okay. You can also have, precision type ohm meters that are standalone instruments, as well as what's in a multimeter. And all of them measure resistance by supplying a known current through the resistor or circuit that you're trying to measure. And it basically is doing an Ohm's law calculation. So since it's a known current, it's measuring the voltage drop and then calculating what the resistance would be, whether it's analog or digital. The digital ones are actually doing mathematical calculations. The analog ones are done because the scale on the analog meter is essentially marked with the Ohm's law ratio. But in all cases, it's going to measure out ohms or kiloohms or megohms. If you're trying to measure a circuit that has a large capacitor in it, you're going to see a very low reading initially, maybe even 0, and you'll see it increase until the capacitor is charged up. And then it will tell you what the resistance of that circuit is after you've charged up the capacitor. If the circuit had a large inductor, it's going to behave the opposite. When you first measure it, you're going to see a very high resistance. And as the inductor charges and builds up the field, the resistance is going to decrease. And the other thing is, like we said before, if you're trying to measure resistance, you don't want to be doing it on a circuit that has power on it. Or you might be buying a new meter. So how is an ohm meter connected to a component to measure its resistance?
Ooh. Mm-hmm.
I didn't hear that.
Bravo.
Bravo.
Are we sure?
No.
It's parallel.
All these choices are correct.
What's cascade? What's
In
cascade?
parallel, in cascade.
Cascade would kind of be the same thing as series.
Okay.
Well, let's go with alpha.
Yeah.
Didn't we say alpha first?
No, we
I
said
guess
Bravo
we did.
first.
Oh yeah, you're right.
Then
I
you said
remember
alpha.
that now.
Yeah. You said then you said parallel, and I went, well, what's cascade? Wait a minute. Cascade, isn't that detergent, dishwasher detergent?
The only one that you measure in series is current.
Oh. Okay.
Voltage and ohms you do in parallel.
Gotcha.
Which of the following precautions should be taken when measuring in-circuit resistance with an ohm meter?
Bravo.
What reading indicates an ohm meter is connected across a large discharged capacitor?
Increasing resistance with time. Alpha.
All right. Now, and that's because it's a discharged capacitor. If it was charged up, you wouldn't see the current change.
Hmm.
Okay. Ammeters. Once again, there are separate units to measure current much more accurately. Some of them for measuring AC current is actually has a clamp-on device, and it's an inductive pickup, so you can measure AC current. It has to be inserted in series in the circuit. It can either have an analog or digital display. It's going to measure in amps or milliamps, maybe microamps. Once again, you need to make sure that it's rated for what you're trying to measure. Usually on a multimeter, you'll have kind of two settings. One for high current, where you have to move the test lead, and one for lower currents, maybe up to an amp or so. So what instrument is used to measure electric current?
Delta.
When configured to measure current, how's a multimeter connected to a component?
Alpha.
Alpha.
Oh,
I have to learn how to do that.
I forgot to delete this one. Or did I? Oh no, we talked about that. Okay. Excuse me.
Oh, wait.
Talk a little bit about soldering. If you are into building things, then you kind of need to know how to solder. Otherwise, you don't. But even for troubleshooting, if you're trying to repair something, you may have to unsolder and solder components to replace them. For electronics, you only use what's called rosin core solder. The actual solder wire is hollow and has this rosin compound, which they call flux, which helps clean the surface when it heats up and vaporizes so that you get a better connection. There's acid core solder, which is used in plumbing. It also hollow, but it has an acid type flux, and it's kind of corrosive. So you don't want to use that on electrical components. When you're doing it on plumbing, it gets washed off after you've soldered the joint. The main thing you have to do in soldering is ensure that you heat. Usually you're connecting two things together. It could be more than two. You need to get them all at the same temperature so that you get the solder to flow. If you're only heating up, say, the wire and not the connection that it's connected to, you're not going to get a good solder joint. You need to be able to heat them both at the same time. And sometimes that's a little difficult to get your soldering iron tip in the right place.
Mm-hmm.
And you can really, when you're doing it right, I mean, it flows quickly and nice. You get a nice shiny joint, usually kind of like a Hershey chocolate top sheet.
Yeah.
If it's a bad joint, it's going to kind of be a dull gray looking thing, maybe kind of grainy or lumpy, not a nice, smooth, shiny surface. And usually that will be a high resistance joint if you were to actually measure it. So which of the following types of solder should not be used for radio and electronic applications?
Alpha.
Acid core.
Because we read the question.
Actually,
which of the following types should not be used for radio and electronic?
there's some misspellings on there too.
Yeah, there's one on the other one too, shiny instead of shiny. So it's okay. I overlooked it.
But in this case, most solder that you will use for electronics is going to be a lead tin mixture. Not sure I've ever seen a tin copper solder.
I haven't. I've never. But the rosin core solder
Is what you use. Acid core is what you don't use.
Yeah.
And actually, I use extra flux when I do it.
You use extra what?
Extra flux. You can buy solder flux separately.
Mm-hmm.
So I always put that on first. You can't have too
What
much
does that
flux.
do?
It helps clean the joint.
Oh.
Because unless it's really fresh, it may have some oxidation, particularly if it's copper. So what's the characteristic impedance of a cold tin lead solder joint?
You didn't tell us.
Yes, I did.
Well, it was a bright, shiny surface on the
But
one.
that was for the rosin
one.
core solder, right? Oh, well, is rosin core and tin?
Tin lead, was that dark black spot also? Or a rough, lumpy surface. You don't want a rough, lumpy surface.
You told us, wait a minute. You told us the characteristic appearance of a good joint on an electrical radio thing would be bright and shiny.
Bright, shiny.
Then that's what we would get with a rosin core.
Yeah, but he's talking about a tin lead, so that's probably going to be the one that he said something about dark black spots, I thought.
Read the question. What does it say? Characteristic impedance of a cold tin lead solder joint. That means a bad joint.
Oh, well, I don't know
well,
that.
we didn't know. Why would we know that?
We didn't know. Okay, so it's going to be Charlie.
But we don't know that a cold tin lead. You just told us on the previous slide that tin lead is the most commonly used one, something for something.
Right. Yeah.
I don't understand. So what is tin lead? I'm sorry, I'm not getting good audio because I'm interrupting probably. So is tin lead an alternative to rosin core? Are they like choices or a different state?
I have another question. Is that lead supposed to be LEAD? Where it says tin lead solder joint? It's LEAD, so...
It should be tin lead, LEAD. Yes,
I'm going
to answer your question, most electronic solder is a tin lead combination. In some cases, it might have a little bit of silver in it. And usually rosin core. I don't think I've seen any that doesn't have flux.
So a cold tin lead solder joint is simply one that it is neither good nor bad, is it?
Well,
it's just.
Would it be just like looking at a circuit board and saying, "Oh, look, that's a good joint," and there it is, and it should be tiny. Is that what you're talking about when it says cold tin lead solder joint? I'm looking at a circuit board and I see them already put together.
what they mean by the cold tin lead solder joint is it wasn't heated hot enough, so the solder didn't flow. You didn't get the nice shiny surface.
So Charlie,
well, when I've done
there's
it
a lot in
badly,
that
I've gotten
question that
alpha.
So when you're soldering and the solder starts to melt, and the rest of the joint is not hot enough, it doesn't flow onto it, but you could melt a blob of solder and think maybe you soldered it, and they call that a cold joint because you didn't get it hot enough. And it doesn't make a good connection.
So
So
Charlie,
then we'll probably have a rough, lumpy surface and just be like that.
Right. It'll just be a blob of solder and it won't be shiny.
Okay.
this kind of expects us to know some things that we didn't know, obviously.
But now you know.
Now we know.
Yeah.
That's true, we sure do.
Got that straight away.
Okay, so we talked about multimeters and what they do and what not to do with them.
Mm-hmm.
Voltmeters basically are for measuring electromotive force or electric potential or voltage, whatever you want to call it. You have to connect them in parallel and make sure that it's rated for the voltage you're trying to measure. Similar with ohm meters, it's a parallel connection. If there's power on the circuit, it could damage the ohm meter. And if there's a capacitor in the circuit that you're measuring, you're going to see the resistance increase as it charges the capacitor. And for an ammeter, you're going to be connecting that one in series instead of parallel, and you're going to be measuring the current through the meter and the device you're connected to.
It looks like part of that slide is missing because it stops down at connected in series. So if there was a third point, it's not being seen.
Can you move the slide down? Up, whatever, yeah.
No, because it doesn't have it on there either.
Was there any more, were there only 2 points on that last one?
No, I don't think so.
There should have been a third point. Can you go back to it? See if I, real quick.
On ammeters, are there only 2 points?
Well, the only other thing you would add is a
No, it's cutting off. We're just asking, is there anything below connect in series?
Yeah, because that's what we're not seeing. It literally almost cuts connect in series in half.
well, it's cut off on mine too, so I can't say.
Okay.
But if there was
okay.
a third, it would be to make sure that it's rated for the amount of current you're trying to measure.
Okay.
On soldering, you need to make sure that you're using rosin core and not acid core.
Right.
And to use enough heat to get good solder flow so that you melt the solder and it flows onto the joint, which means everything is heated up to the same temperature. And that's how you get a nice, shiny, not cold solder joint. If it looks kind of dull, kind of a dull gray or grainy looking, usually they're more of a dull gray from what I've seen.
Mm-hmm. Mm-hmm.
It indicates that you don't have a good joint because it didn't get hot enough.